All right, let's dive right into this. Welcome to today's Explainer, where we're going to completely change how you look at one of the absolute highest operating expenses in any heavy-duty business. You guessed it, fuel. We aren't just talking about, buying diesel and pumping it into trucks. We are tracking the entire journey of a drop. We're going to look at how a comprehensive fuel management system gives you total 100% visibility over every single liter, from the exact moment it's purchased to the very second it gets consumed. Think about your accounting department for a sec. At the end of every single day, you likely reconcile your cash registers, right? You count the till to make absolutely sure the money going in matches the money going out. But what about your fuel tanks? The core foundational concept we really need to grasp today is this. Fuel is liquid gold, and you need to manage it exactly like cash. I mean it. Fuel sitting in a tank on your site is literally no different than a stack of $100 bills sitting in a cash drawer. It's just money in a different state of matter. Just picture gold pouring straight out of a barrel, and this brilliantly illustrates the incredibly high stakes of untracked fuel shrinkage. When a liter of fuel goes missing, whether that's through a leak, some undocumented transfer, or flat-out theft, that is literal cash leaking right out of your bottom line. Think about it. If your operations team wouldn't accept a cash register being short a few $100 at the end of the day, why on earth should they accept a fuel tank being short a few hundred liters? All right, Section 1. Fuel is liquid gold. Let's get into it. To really cement this whole mindset shift, let's just break down the exact math. It's literally the same exact discipline, just using different units. So for daily cash control, you take your opening cash at the start of the day, add any cash sales received, subtract the purchases and payments going out, and boom, that equals your closing cash, exactly what the drawer should hold. Now look at daily fuel control. It is identical. You take your opening stock, the actual liters in the tank at the start of the day, add the fuel received from your vendors, subtract the fuel issued to your assets, and that equals your closing stock. It's what the tank should measure. You measure that tank and reconcile it every single day, just like counting the till every evening. Moving right along, Section 2, the 3 fuel paths. Okay, so to actually track fuel like cash, you absolutely have to map exactly how it moves. Today, we're going to demonstrate the 3 common fuel movement paths from vendor delivery to asset consumption. That's the real core of this. Here's the simplest flow. Path 1, the direct issue. In this scenario, there's no centralized storage tank sitting around on your site. The fuel moves directly from the vendor, maybe a local fuel station or a delivery truck, straight into the asset itself, like a piece of ground support equipment or a freight vehicle. You buy it, and it goes right into the machine doing the work. This one entry essentially acts as both the purchase and the issue, all at the exact same time. Next up, let's move to and see how this built-in complexity. Path 2 is via storage. We see this one all the time. Here, the fuel is delivered by the vendor into a static storage tank or maybe a series of barrels sitting on your site. From that storage, it's then issued into the asset when needed. So this requires a 2-step tracking process. First, your storage stock goes up when the delivery arrives. Second, your storage stock reduces and your asset consumption goes up when you issue that fuel out to the equipment. Make sense? And finally, we have Path 3, full flow. This is the whole shebang. It's the heavy-duty path used by massive sites like mines, huge construction zones, or airports. Fuel moves from the vendor into a massive main storage tank. But because the heavy machinery is out working in the field and obviously can't drive all the way back to the tank, the fuel is then transferred into a mobile fuel bowser, basically a specialized fuel truck. That bowser then drives out and finally issues the fuel directly into the asset. In this full flow, you have to track the transfer from static storage to mobile storage, and then again from the mobile storage to the final asset. Which brings us to Section 3, measuring every liter. Now, no matter which of those 3 paths your fuel takes, the real moment of truth happens right at the point of refueling. Operators need a totally standardized process. First, they use whatever method is available. An automated fuel dispenser is best, obviously, but a flow meter, a station pump, or even manually measured cans work perfectly fine as a fallback. Second, they have to record the exact liters added. And third, guys, this is absolutely non-negotiable. They must attach photographic proof of the meter reading. Why? Because you should always aim for a full tank every time to calculate accurate full tank to full tank mileage. Even if you can't fill it all the way up, capturing the exact volume with a photo ensures 100% accountability per transaction. No way around it. But here's the thing, tracking the volume of fuel you're adding is really only half the equation. To actually know how efficiently you're using that liquid gold, you have to track the work the asset actually performed. And this is not a one-size-fits-all metric. Depending on the equipment, operators have to capture the corresponding asset meter. For generators, pumps, heavy static plant machinery, you track hours. For trucks, cars, and vans, you track kilometers. And for electric assets or diesel generator output, you're tracking kilowatt hours. Pairing the right meter reading with the exact liters added is literally the only way to measure true consumption.
And that brings us to the ultimate goal here, establishing your standard consumption rate. It's a pretty simple formula. This rate is just the fuel consumed divided by the usage, whether that's hours, kilometers, or kilowatt hours. By tracking this consistently day in and day out, you establish a real solid baseline from actual on-ground performance. Once you know exactly what a specific dumper truck or generator should consume, your system can automatically trigger alerts when it suddenly starts burning more than its standard rate. It lets you catch those expensive issues immediately.
All right, on to the final stretch. Section 4, closing the loop.
So, we've got the fuel paths mapped out, we've got the field data captured. How do we actually close the loop? Well, we have to move away from what is often a fragmented nightmare. Paper fuel slips blowing around the cab of a truck, separate clunky Excel files for different sites, vendor invoices stuck in some finance department inbox, and sensor logs that literally nobody ever actually reads. We move from that chaos to a digital control system where every single movement is recorded once. Your physical stock, your financial cost, and your asset usage are all perfectly in sync. Everything is traceable, everything is validated, and absolutely nothing gets lost.
So the crucial point is how we actually validate all that data, and we do that through the 3-layer control model. Visibility only becomes completely ironclad when these 3 sources compare their notes. Layer 1 is mobile/manual. That's your field operators actually recording the real-time movement, the asset, the quantity, and snapping that photo proof on their app. Layer 2 is finance records, the accounting team capturing the purchase invoices, checking vendor rates, and verifying receipts. And Layer 3 is IoT sensor data, the hardware actually validating the refueling events, tracking the tank level drops, and spotting any weird abnormal consumption. Basically, when the field app, the finance ledger, and the tank sensor all agree, your reconciliation is bulletproof. Let's talk a little bit more about that final IoT layer, because it completely elevates the whole system. These sensors don't just flag that you lost fuel, they pinpoint exactly why you lost it. If a discrepancy pops up between the 3 layers, IoT helps you diagnose the root cause immediately. Was it physical leakage, meaning shrinkage during refueling, maybe unauthorized draining, or even a punctured tank? Or was it operational inefficiency, meaning the fuel actually did go into the engine, but a maintenance issue or just bad driving habits caused the machine to burn way, way more than its standard rate? Knowing the difference is absolutely the key to fixing the problem. Which leaves us with this final thought for you to take away today. I really want you to take a hard look at your current operations. Tomorrow morning, when your tank inevitably measures a little bit short, do you know if it was a mechanical leak, an inefficient engine burning way too hot, or outright theft? If you honestly don't know the answer, you are leaving your liquid gold totally unguarded. Map your fuel paths, measure every single liter, and close that loop. Thanks so much for joining us for this explainer, and we will definitely see you next time.